Hello everyone, in this video I'll be solving the first problem which was asked in Biweekly contest 158. So the first problem, it was maximum y sum by picking a triplet of distinct x values. You are given two integer arrays x and y. They have given two integer arrays x and y of each length n. Okay, so you must choose three distinct indices I, j and k such that x of I not equals to x of j not equal to x of k not equals to x of I. Okay, your goal is to maximize the value of y of I, y of j, y of k. Under these conditions, return the maximum possible sum that can be obtained by choosing such a triplet of indices. If no such triplet exists, return -1. So okay, let me explain you in the board. So x they have given 1 2 1 3 2. Okay, so x they have given is 1 2 1 3 2 and y they have given is 5 3 4 6 2 5 3 4 6 2 5 3 4 6 2. Okay, so let's understand this problem. So what they're saying is you'll have to choose indices in x y, indices I j and k in x such that x of I not equals to x of j not equals to x of k and x of k not equals to x of again I. So basically the indices what you're choosing in x, that has to be all different. I mean indices has to be different and their values has to be different. So if let's say you're choosing I as this and j as this, you cannot choose k as this, because in this case x of k is 1 and x of I is 1, so 1 not equals to 1 is false, so you'll have to not choose that. So what you can choose the next one, which is basically k. Let's say so corresponding values, if you see, that will be 5 plus 2's corresponding value will be 3 plus and 3's corresponding value will be 6, and if you sum up that will be 8 plus 6, which is 14, and this is the maximum possible answer. Now if you choose let's say 2, so this answer will be 13, so which is not maximum is 14. So in the next iteration what you will do, you will take this one, but this is not accepted because I and j are equal, so you'll have to choose this one, let's say. So in this case k will be choosing this one, so again the sum will be 5 plus 6, which is 11 plus 2, which is 13. Okay, so I think pretty much we got the problem statement. So brute force approach would be you can take 3 for loops, which I will be running from 0 to n minus 0 to n minus 2, and one more for loop you can take j, which will be running from I plus 1 to n minus 1. This is n minus 3, this is n minus 2, and one more loop that is for k, which will be running from j plus 1 to n minus 1. Okay, and you will have to check here if condition, if x of I not equals to x of j and x of j not equals to x of k and x of k not equals to x of I. So if this condition is satisfied, then you'll have to take let's say one max val variable, which will be initialized to let's say int minimum. Now you'll have to take max val as max of max val comma y of I plus y of j plus y of k. So this is the extreme brute force solution, but if you see in the problem, they've given n is 10 power 5, so 10 power 5 3 loops means it will be 10 power 15, which is much greater than 10 power 8, so you will get TLE, time limit exceeded. So let's try to optimize the solution. So one thing we know is that let's try to check the optimal solution. Now one thing we know is that we'll have to choose the values distinct from this x. Okay, so let's say what we'll do is we'll choose distinct values 1, 2, 1 is there, so it is here only. Now 3 and 2, one more is there. So distinct values from the x we've taken is 1, 2, 3. Okay, that is good. But see, in this case, one's corresponding value is 5 and one's corresponding value is 4. So which one is greater? Because we need maximum. So obviously this one. So we can take one's corresponding value as 5. And if you see second for 2, 2's corresponding value is 3 and 2's corresponding value is 2. So the maximum value what we have is 3. So 2's corresponding value is 3. Now if you see the third one, I mean for the 3, we have only 1 3, so its corresponding value is 6. Okay, I think you got like we will have to choose the distinct values. So okay, and in distinct values the max corresponding value whatever you have, that you take it in a map. So basically what we'll do is we'll take a hash map, and first we'll take one's corresponding value is 5, and next time when we come we'll take 2's corresponding value is 3. Third time when we come, 1 corresponding value is 4, but we'll take max of that. Max of 5 comma 4 is 5 only. And when we come to 3, 3's corresponding value is 6. When you come to 2, 2's value is 3, but max of 2 comma 3 comma 2 is 2 3 only. So this will be in our map. So once we got this, see whatever pair we are getting, right? So we need to find the 3 max values. I mean first max value, second max value, and third max value out of these 3. So we'll iterate through this map and trying to find the first largest value. First largest value will be 6. Second largest value will be, if you see this is 5. Third largest value, that will be 3. So if you sum this will give you 14. Okay, so this will be the max. I think I pretty much got what I'm trying to say. Basically we'll find the distinct values from that, and corresponding value for the distinct whose value is max, that will put in the map. And in the map we'll do an linear search, and we'll try to find first largest value, second largest value, third largest value, and we'll try to sum them up. In one of the, let's say in second case, which in question they have given, second case is 1 2 1 2, x is equal to 1 2 1 2, and y is equals to 4 5 6 7, and y is equal to 4 5 6 7. So if this is the case, in that case same, our map will be 1 comma 4, but here 1 is 6, so this value will be updated to 6. If you see 2, 2's max value is 7, so this will be the case. But in this case we can only have 2 values, but we need 3 values, right? So in this case we'll have to return -1, because we cannot make triplet. So that is the thing. So I think pretty much you got the problem statement. Let's try to code it up. Brute force solution I'll not be coding up, that is very easy, you can do it, but I'll be solving the optimal solution. First what I'll do is we'll take one unordered map, okay, that whose type will be integer, an integer m. We'll take n, which is basically size of the array. We'll iterate through the array I less than n, I plus plus. In map we'll be inserting m of x of I. This is basically x of I, whose value will be max of m of x of I comma y of I. So max value we are storing for that corresponding x of I value, and here we'll do check if m dot size, which is basically map size, is less than 3. So in that case we will have to return -1. Else we will find, let's say, first largest value, which will be initialized to, let's say, int min. Okay, we'll take in second largest value, which also be initialized to int min only. We'll take third largest value, which will be initialized to again int min. Okay, so we'll iterate through this map, and we'll try to find the maximum 3 elements. Okay, so we'll take int val is equal to I dot second. This is the value we are getting from the map, and we'll find if this val is greater than equals to first largest value. If the greater the value what we are getting from the map, it is greater than equal to first largest value, in that case what we'll will update the third largest value to second largest value to first largest value, and first largest value will be updated to val. Else if we'll find if val is greater than equals to second largest value. Okay, so in that case, which means first largest value is the first largest value is greater than value, so we're not updating anything, but this condition is false, which means we are going to check the second largest value. If the value is greater than second largest value, then in that case our third largest value will be the second largest value. So third largest will be second largest value, and second largest value will be val. Else we'll have to check here if val is greater than third largest value. If val is greater than third largest value, then we'll have to update third largest value to val, and at the end we'll have to return first largest value plus second largest value plus third largest value. Let's try to run the code. Okay, let's try to submit the code. Yeah, it got accepted. So let's try to analyze the time complexity of this algorithm. So if you see here, this is a for loop, so it is O of n, and this one is also, let's say, all the elements in the array are in x array are having distinct value, then this will also be running like n times. So basically O of 2n. And if you see the unordered map you are using, so if let's say we have all distinct values in x, so all the elements will be storing in maps, so that will also be O of n. So the space complexity will be O of n, both the time and space complexity will be O of n, which is linear. So thank you guys for watching the video.